Hi, my name is Carl Shotwell. I'm a graduate student in Andy Bergwin's lab, and I am kind of in an interesting position where I'm a University of Florida student, but I'm doing my research at the University of Albany, and I'm in the second year of my fellowship. My project is it's engineering synthetic RNA binding proteins in order to better understand the mechanisms of myotonic dystrophy as well as potential therapeutics. And so that's a lot of big words. So what does that mean? What we're basically doing is taking the MBNL protein, the protein that's responsible for, or the one that's being sequestered away by the toxic RNA present in myotonic dystrophy, and we're basically trying to take that protein into what its most basic parts and understand what's important and what's not important for various functions of how MBNL works. And why we're doing that is we want to understand, can we basically separate how MBNL binds to the toxic repeats and how it does its function? And if we can we then use that to develop a therapeutic that binds to the repeats and prevents the MBNL that's normally present in your cells from doing so that it can do its normal job in the cell. So the hope is that either we can create a protein that can be used as a therapeutic so that it can bind to the toxic repeats that are present and prevent MBNL from binding. And when it prevents MBNL from binding, MBNL can go back into its job, and then you wouldn't have the phenotypic effects or the side effects like the myotonia that's present in the disease. If that doesn't pan out, help us understand better how MBNL works so that we can better design therapeutics in the future. My overall goal is just really trying to further our understanding in the field because there's still a lot of things that we don't understand about the disease. And if we can further just a little bit our understanding, then it's going to help us, others, us and others to really better develop therapeutics for the disease that can be used as treatments, cures. So the foundation means a lot to me. I was lucky enough that I actually got to go when I was a first-year PhD student to IDMC and MDF. That was the one that was in San Francisco. And it was really nice being able to, talk to families and actually understand what is the biggest problems that they have on a day-to-day basis. What are the worst things that they think come about because of the disease? And then taking that back into the lab and saying, okay, can we study that now and understand really what the differences are? And then can we understand, why that's happening, and then how can we fix that? And I think that MDF provides a really nice resource for us to do that. I think it's a really interesting time right now for the myotonic dystrophy field. We have, there's a lot of clinical trials that are being started in the field, a lot of therapeutics. There's a lot of interest in finding a treatment for the disease, both at industry level and at academia level. And I really think that, engineered proteins are, one way to do that, one way to treat the disease. But I also think that, we need to also keep studying the basic science of myotonic dystrophy in order to help us understand more about what's happening in the disease so that we can better develop therapeutics and develop therapeutics that have fewer side effects and fewer off targets. So really understanding that basic science of the disease, I think, is key.